I'm Lynn Langit, and this is Teaching Kids Programming with the Intentional Method. Thank you very much for coming out at the end of a long day. I really appreciate it. So Teaching Kids Programming is a global nonprofit that I'm the co-founder of. I've been doing this work for about 8 years. So the earlier years, I was an employee of Microsoft, and I did the work specifically focused on young girls. It was called DigiGirls. So the nonprofit's been around for about 4 or 5 years. I'm a professional programmer. I do this as a part of my professional life. I'm a big data and cloud architect in addition to this. Our primary output is a set of free and open source materials that are intended to be used primarily by school teachers, targeted at middle school aged children. And I'm going to give you a preview of our curriculum in this session. Everything is free. So you'll see a lot of pictures because I think that there's no better way to understand the importance of working with kids than to actually start and try. And hopefully I'll inspire some of you if you haven't yet spent some time working with children. It's an incredible experience to see what kids are capable of. You'll see lots of pictures like this where we have 2 students sitting in front of a computer. It's because in addition to our curriculum, we have a set of techniques that we advocate for in teaching. And these techniques come out of our programming community. They're extreme programming techniques, the first of which is pairing. We are quite insistent about pairing while learning. There's been quite a lot of research in cognitive science about enhancement of the learning process, particularly for girls. And I have some resources I'll point you to at the end of the talk. So you'll see quite a lot of that. You see a lot of happy, smiley, joyful faces in the pictures that I'll show. So the core of Teaching Kids Programming is a new method of teaching. The materials that we use in many ways are repurposed. For the Java curriculum, which is just one of the curriculums that we offer, you'll see something that's probably familiar to a lot of you, an implementation of Logo. So yes, the turtle. But our turtle is a little bit different than turtles you've seen before. So the core of the TKP teaching method is something we call intentional teaching. And it comes out of our own experience as programmers, having learned in what was really kind of a boring way, right? You guys all remember that. Maybe it wasn't boring for you, but it was boring for me. The console app, right? Hello world, woohoo, right? Copy this code. Our method is based on Socratic teaching, which is exploratory, interactive teaching that attracts a broader variety of people into the programming world, which is one of our key and core goals. So very simply stated, our recipes or courses or lessons contain a set of English instructions, and we very carefully work to make sure that those English instructions are translatable into one line of, in this case, Java code for this talk, and that the kids can then run it and see the result. It's a very TDD style of learning programming. We find that having this ability to immediately see the results of what you're making is a key engagement aspect for working with kids. So I'm going to show you what it looks like as well. So 1 line of English into 1 line of code. So you might wonder, why Java? Why are you doing this old? Although there's a lot of Java people here. I get a lot of resistance. I live in California, and everybody there is doing Ruby and Python and all the new languages. And we have found that this method works with other languages. I actually have more of a database background. I've actually taught T-SQL using the intentional method. And we are working to develop other types of courseware in other languages as well. But our core focus at this time is to develop a Java set of courseware that can be used in our schools to introduce middle school aged children to programming. We have about 25 hours worth of courseware right now. Our goal is 30 hours. And I've committed to the team that we'll be complete with our courseware by January 2015. It's being tested in some US schools right now, and you're welcome to, if you like it, to use it in Sweden as well. But the idea is that we'll have the Java courseware as a first set, and then I'm thinking, if I say it out loud, I guess I'll have to do it, that Python is going to be our next language. I'm thinking that. You guys can talk to me at the end too. But in this talk, we're going to focus on Java. So the core principles of TKP Java are as follows. The courseware itself is on GitHub. It's free and open source and always will be. We're committed to being free and open source in our TKP Java courseware. It needs to be fun. My daughter, who's now 15, has been involved in this effort since she was 8, and we always have what we call the Samantha test. If it doesn't pass Samantha, it doesn't quite make it. So she has the, or she has the, or she has the. Okay? So if we don't get the, we go back and we work on it, because if it's not fun, it's not worth doing. We do test on girls and boys, and we pride ourselves in having courseware that appeals to both. We have a customized IDE. You'll see when I demonstrate the courseware, the download that you use from GitHub has a customization for Eclipse that we've thought quite a lot about. There are a number of aspects. And this came out of some work that we did with a language from Microsoft called Small Basic, which has a customized IDE. We had some really good success with in having kids be comfortable. But to be clear, we are using Eclipse. We're just doing quite a lot around customization, menu items, templates, and configuration of the Java docs. And as I said, our teaching practices are an implementation of XP programming practices. So we have a core of pair programming. We advocate for pair teaching. The most optimal is if you had a man and a woman teaching, because we like to model that which we're asking the kids to do. And we have a number of additional practices around XP, the rapid feedback. We actually advocate that the kids, when they switch roles between driver and navigator, you set it on a timer and they stand up and they switch. Because again, there's cognitive science around if you're engaged mentally, if you get up and you move around physically, you can absorb more of what you're learning and have a better time. So we've documented all this in a written set of instructions that are intended to be used by teachers. It's on something called PenFlip, which I'll show you at the end. It's about a 150-page book, if you will, that talks about this. And our courseware is designed to be modular and flexible. We have 8 courses, and each course has up to 8 portions, so that you can teach it at any rate that is convenient for your particular situation. If you're hosting a club, like I had the great fortune to go over to your Coder Dojo last night, which is fantastic, and work with some of the kids, you can do one little subset for 15 minutes, or if you're teaching a weekend event, for 3 hours, you can do several modules at a time. You can also be flexible in terms of if the kids are a bit younger, or if the kids have a little more experience, a little less experience, you know, it's very flexible. So like I said, we advocate for pair programming, and I really can't say enough about the importance of pairing. We get a lot of resistance, probably like in the real world, often from the parents, who either aren't programmers, or if they are, they don't pair themselves, who think that there's somehow diminished value if each student doesn't have a computer in front of them. So again, I really encourage you, if you're interested in our methods, to take some time to read the section. I'll show you where it is in PenFlip. Talk about pairing. And if you're a programmer and you don't pair, watch the kids pair, and then maybe you'll try it. So, okay, here's our set of courses. And this is we're teaching 11 to 14-year-olds. It is funny because we've actually had adults say, can I sit in or learn these things? And we let them, but they have to pair with other adults. And they're invariably much slower than the kids. So we actually have quizzes too, and this is really funny. The programmer parents will bring their kids, and the kids will usually complete the quiz more quickly than their programmer parents, which is pretty funny. But anyway, so this is our set of courses, and it's everything from the very first thing where you sit down, and I'll show you sections from these courses, all the way up to, yes, we teach 11-year-old kids TDD. Yes, we do. Yes, we do. Okay, so each course, once we're complete with our library, and we're not complete at the high end, the TDD doesn't have all this yet, has these sections. So in this talk, I'm going to give you little previews of these sections. So the recipe takes about 30 minutes, and again, it varies, but I'm going to give you like 3 minutes. So, because I can't, in a 40-minute talk, do the whole thing. You can see that each course takes about 3 hours. A little bit more, a little bit less. So we have, and each course teaches 1 to 3 programming concepts in different types of ways. One core aspect of our courseware is mastery-based learning. So it's analogous to, I think, the way math should be taught. I am not a K through 12 teacher, but my feeling is that to properly learn mathematics, you need to have mastery of the preceding concepts so that you can learn the subsequent concepts. And that's our feeling about programming as well. So we need to start with the recipe. So let's do that. So we have a customized IDE, and right now we have everything kind of all glued together. So you'll see inside of here, I've done some of this, and you can see there's fewer buttons here. And you know, yay, there's the turtle. So now what we would next do is we would have the kids read the line of English. So the way the class would go is I would say to the class, please read the line of English, and then they would read it, turn the tortoise 90 degrees to the right. And then I would say something like, what is the subject? And they would say tortoise, and I would say type T-O-R. And then we have also this XP practice of knowing your tools and taking full advantage of them. So we would say, to complete that, what do you do? Control space. And this is our library that we've written. And you can see the little enhancement there. We have the tortoise graphic. So we have all kinds of little things that we've done like that. We've also put in basically Easter eggs in the documentation. Things like girl programmers are cool and boy programmers stink, which, you know, just makes the kids have a great time with it. So we'll say turn, okay, and we'll say 90. And then we've done some things in terms of code formatting because it's overwhelming for kids with Java, with the braces and all that kind of stuff. So you notice, if you look really carefully, if I type right now a semicolon, see how it goes to the end? And we've done, you know, I think thoughtful things in the environment itself. And then there you can see that it is. And then we will have them clean up the English because they no longer need it. And again, that drives some professional programmers crazy. You know, like, well, you need to have the comments. And our feeling is that if you have very expressive code, you do not need to have the comments. So in addition to the recipe, we have some utilities for teachers. And one of the utilities is something called a virtual proctor. So I'll demonstrate how this works. So to set the name of this machine, I'm going to have to go virtual proctor. This is something we'd guide the kids through. Say set name, and then I'll say hello Malmo. And I can't use Swedish characters. I found out I have a bug on that today. So if you use this, I'll get that fixed. And then I'm going to go ahead and run this. And we've hooked into the on-close event here. And now, this is the virtual proctor from a technical point, since this is technical audience. This runs a Google App Engine. The reason we picked it is because it has such a generous free tier. And this should refresh, and I can move this we got some other kids coding around the world, which is super cool. And there it is, down there, hello Malmo. And you can see, you can lay this out. Now, this is as you can see, this is like super crude. So some of you might be inspired to join our efforts, and we could clearly use some programming sophistication around this. So if you look at this and go, yeah, that's kind of crap, well, give me a Skype, and we can work on it together. It does function, and it's really a lot of fun when we get to the sort of what we call the variation part of the lesson, because you post this up, and the groups of kids just get into this competition like, oh, how did you do that? Oh, that's so cool. Oh, it's so fantastic. Which, again, adds to the sort of fun and joy that we're trying to bring to coding. So we are very much about know up front. And this comes out of, the agile world, if you will. We get the kids sat down into pairs. They are executing their first program within 3 minutes. So we're doing experiential learning. There's no lecture, there's no explanation. It's you sit down, you type this, you run it, whoo, you see the turtle. We backload. Once the kids are engaged, you'll see in the pyramid of the courseware, then we will fill in. Oh, by the way, that turtle thing, that's a class. That set name, that's a method. It's like a verb. Because once the kids have spent some time coding, then they care. They don't care if they are just having a lecture. So, all right, and that's the virtual proctor. So I had the, okay, I'm going to try. Avsiktlig svenska. Close? Intentional Swedish? My Swedish is horrible. Okay, so I had the really good fortune to meet somebody in my audience here. Do you want to stand up? Mateus? At a conference in the United States about a month ago, where we were presenting a seminar on this topic. And he came up to us at the end and said, I'd really like to get this going in Sweden. I said, where do you live? He said, Malmo. I said, that is fantastic, because I will be there in a month. So I came in a bit early, and on Monday, we went out to the school where his daughter is, and we taught a class together. So at the end of a talk today, he was so kind to come in, even though he wasn't attending the conference, you can get sort of the real thing, how it goes. The point, though, that I wanted to make right here is in working with middle school children for whom English is not a first language, I have had very good success in the beginning, having them say the English, type in this case the Swedish, and then go to the Java. Because the core of our method is that the kids know what it is they are building. As contrasted to what I've seen out there for so many years, which is a well-meaning programmer up in the front of a group of kids, having the kids just copy the code. And the kids really have no idea what they're doing. It seems like a subtle thing, but it's a really important thing, that the kids need to understand what they're doing. Even to the point of the people who are teaching the class, when we work with training with teachers, we ask them not to complete typing the line until more than half the class has completed it. Because the kids need to work together to discover the answer. It's really a critical point. So once they get through the recipe, they've learned quite a lot, but they haven't really had any conceptual understanding. So the second portion of our courseware is we ask the kids to close their laptops, and then as teachers, we repeat what they've done, but we do this in an interactive way. So we say, okay, what should I do first? And the class will answer. What should the person type? Why are they typing that? In addition to that, we will purposely make mistakes. So we'll do things like this. We will say, okay, let me get something that is good here. So make the tortoise move as fast as possible. So if we were doing the recap, this would already be, they would have seen it, but we'll say set speed, and then we'll go here, and we'll say set speed, and control space, and then we'll purposely leave out the required parameter, and then we'll purposely run it, and we'll say, oh, what's wrong? What's wrong, right? And then we ask the class to tell us what to do. And we point out, because again, we're teaching them to use their editor, that they should be, looking. I'm sorry, this is small, but I can't change the font of that. And obviously, they're missing our parameter. Now, another thing that we've done is when we wrote our libraries, we wrote examples and thorough documentation for every single class and method and object. Because we want to teach the kids the right habits, which is to read the documentation, which we all do, right? We all read the documentation. So yeah, we purposely make these mistakes. So we go ahead and we correct it, and then we do that, and then we have a very fast turtle, okay? So other things that we'll do in the recap is we'll do things like for the for loop, which by the way, another thing that we do, it's a little cut off there. Do you see it says I is less than or equal to stop? Very subtle change, but we found that for loops are really difficult as a first concept, so we made that very subtle linguistic change so that the kid could discover, oh yeah, I should stop at 4. That makes sense, okay? But we'll do things like, purposely not do the braces correct, and then we'll say, oh, how come it didn't work, right? And so then, so we introduce the concept of a runtime error. But again, we don't say, oh, this is a runtime error. We just, why doesn't it work? So we start with English. That's always the point, the English going to the programming language. I think one of the key differentiators of our courseware, and one of the reasons it's successful, is because I learned to program as an adult. So I'm not super, I wasn't programming when I was 12, and I have a background in linguistics. So I'm very, very keen on translation layers. And I think that makes it more accessible. And then, of course, we use this sort of keyboard shortcut. So you're going to go, well, do you guys know? How do I move the brace? What's the keyboard shortcut? Does anyone know? I'll teach you something. Alt down. Okay, Alt down. And then I'll run it. Now notice something subtle in the code. Look how it's set up here. And I run it. Do you see the indent? And do I have this in the wrong spot? Let's see. Oh, I have 2 turns. Thank you. Thank you. Audience pairing. It's a great thing. There it is. So it formatted on save. That's another thing that we've added. We believe that kids should not have to do all these very hard things in the very, very beginning. Now, in some of our forward direction, we may make this editor look more like sort of a standard editor. But again, we've done all these things to make the on-ramping easier. All right, and then we have to delete the English, and then we're good there. So there's my daughter, and she's teaching at summer camp, and she's teaching recap. And she taught with Jessica Ellis, who's, stand up, Jessica. Jessica's here with me from San Diego. She's my program director, and her son, Brick, who's 15. Yes, his name's Brick, like Lego Brick. It's awesome. Brick and Samantha taught summer camps because they've been working with this for quite a while. So that's another sort of interesting thing. You know, there's this challenge of not having enough people who can teach. You can take the kids who really are good at this, and they can become the teachers to help scale us into our schools. We've had very good success with that. So another thing that we did with the recap, because it's really tough for school teachers who are trying to learn to program and teach, is we have a YouTube channel, and it's mostly maintained by my daughter. It's me, my co-founder, and my daughter, and some other people, and we have these recaps also recorded. I think it's kind of cool to have a 15-year-old girl be authoritative on Java. You know, it's these things that quietly make the world more inclusive, right? Just sort of natural. So we have that as well. So then we go into the variation. The variation is refactoring, so where we teach refactoring. Yeah, we're ambitious, right? 12-year-olds, TDD and refactoring, but it's super fun. So how does that go? Well, we introduced that with the idea of that we all know in the real world that, you know, you deliver some result and the product owner is not satisfied. So you have then to make changes to it. So we take that real world concept and we do that in a way that's beautiful. So this is actually, well, Jessica did this after a camp where the kids would make these variations, and this is from Square. And they loved them so much that she had the great idea to print them out and have the kids sign them. She also has talked about the idea of maybe making T-shirts after a summer camp with the code on the front and the thing on the back, which I think would be fantastic. So how do we do it? Well, we have this idea of a feature grid, basically. So we start with a blank grid. And then again, using the interrogative method, we say, literally, we say, all right, you've made this square. And you give it to the person who's paying you. And the person says, nope, that's not what I wanted. No, mm-mm. So you, as a programmer, need to learn how to communicate in English again. Well, what did you want? And then you have to say, well, this has certain features. So you say to the kids, what are the features? Well, it's a square. Okay, great. Well, how many sides does it have? It has 4. Okay. What else do you see about it? Well, it has a size. Well, how big is it? It's 50 pixels, right? Because that's how much the tortoise moves. How many angles does it have? So on and so forth. So you record these things up, and then you go to the code and you say, okay, which line of code, and let me go over here. This is done, I think, yep. I changed to random color already, which is something they always want to do. You say to the kid, all right, which line of code, well, you say, in this case, you got how many sides? 4. So you say to the kids, what do you want to, where do you see the 4s? And you see the 4s in line 12 and line 17. So what we introduce here is, again, in the tooling, we right-click, and we say, we tell them what to do, because they're not going to know. Refactor. We say extract local variable, and we say sides, and great. Okay, and they really have no idea what they've just done. But when you then say, go to line 12 and change it to a 3. And you say, now what do you think it's going to do? It might be a triangle. And you go, run it, right? And they go, yeah. And then what do you think they do? Then they completely stop listening to you. And then they go like this. They go like that, right? And they just start going crazy. They start going crazy, right? Which is the whole point. The whole point is that we want to teach a generation how to be creators, not to copy the code we put on the board. So the variation is by far the most fun thing ever with our stuff. So then we also do things like we'll tell them, hey, pen width, you don't want to have 2, make it 20. So you go start playing around with that. And then we say, why don't you try I? Because we haven't explained the I, not at all, not one bit. And then we say, what do you think it's going to do? They go, oh, I don't know. Well, let's run it. What do you think it's going to do? And you go, ah. So you go, okay, what is that? How big is that first one? They go, 1. How big is that second one? 2. That's what the I does. And then you go, okay, let's magnify that. Let's take that times 2. Oh, right? You can literally can see the light bulb on top of their head. Oh, it's the most fun way to learn a for loop, visually, right? Visually. And then again, they're going crazy. They're going crazy. You got the virtual proctor up. Let's see, where it is that over here? Let me go. If I can get it there. You get the virtual proctor up, and they're going, look at what they did, and there's like utter chaos and anarchy in the room, and it's fantastic. So you just kind of let them go crazy a little bit. You do a little bit of guided, so it's guided play. And we've had, we've had kids that they won't eat lunch, they won't go to the bathroom, they're sitting there wiggling around because they don't want to leave. We have kids go home and program for 8 hours, and because we can see it on the virtual proctor. We can see how long they're going. Parents, like, what did you do to my kid? We were in Silicon Valley. And, really snobby there, right? Oh, Java sucks. It's an old language, right? Oh, you should use all these GUI, fantastic things. We had one guy come up to us and say, my daughter, who's 11, came up to me and said, I had the most fun in the computer class. And it was a whole day, there were a whole bunch of classes. And he said, oh, yeah, you must have been in that robotics class. She goes, no, it was Java. It was fantastic. And he's like, what, did you give them something to eat that made them crazy, or what did you do? He didn't believe me. So it was crazy. So this is really common at this point. It's great. All right, then we give the kids a quiz. Now the quiz, everything we do is a little bit different. The quiz is not for the teachers. The quiz is for the students. Because we have taught them so much in such a short period of time, they don't even really kind of know all the things that they know. The other reason is I actually come out of traditional teaching. I taught like C# for years to adults, and I had to take all those horrible certification exams and all that kind of crap. And I think it's just stupid to check for programming competency by doing a written test where you memorize the, I don't know, whatever, okay? You want to check for programming competency by programming. I don't know why that's such a hard concept. So anyway, so here's the quiz. It's a self-grading quiz, and I've partially done it so you can see what it looks like. So you can see you got this weird turtle doing something. And we encourage the kids, TDD style, in a pair, to do each question at a time. And we'll get 100% mastery. So let's try this one. Change the color of the tortoise draws to yellow. Tortoise. Okay, so tortoise. And it's going to be a setter, so set pen color. Notice how I'm doing the camel casing, right? It's something that we teach. If I can get this to come up. Set pen color. There we go. And then I'm going to do colors, because we did a library here. Colors. There it is. And it's going to be yellow. Colors.yellows.yellow. And you can't see it because my screen's cut off, but we actually went through and we show the colors. So we have a color picker, because colors are really important and fun. So now we're closer. Oh, we're almost there, we're almost there. Can we do it? And then we want to change the width of the line the tortoise draws to 5 pixels. Notice it's similar to the recipe, but not the same. And that's by design. Because if we just put 2, they could go back and they can look at it, and if they get really stuck, we tell them to copy and paste, but they can't get the right answer without reading the English. And it was 5, right? Well, let me do it wrong. Let me do it wrong and show you. If I copied and pasted, what am I doing here? Set pen width, thank you. Set pen width, sorry. Typing and talking. I need a pair. So yeah, so it's not going to be right, okay? Now, notice what happens if I put 20. Some of the smarter kids figure this out right away. What happens there? Do you see how we're encouraging the interaction because the reward shape is actually created out of the value? It's a continuation. So the smartest kids pass the quiz really fast, and then they want to keep on doing it. Isn't that funny? A quiz that kids want to keep on doing. So it's super fun. So this is why we wrote the quiz. This was at, doesn't really matter, but it was a Microsoft store in California. And the only two girls, we had this class there, and they hated our class. They hated it. They were just like, when do we get to go home? And their dads brought them, their programmer dads. It was all a bunch of really nerd other people that had programmed forever. Do you see the star? They were the first ones done. See their face? I beat my dad. The dads were really like, oh shit. It was pretty funny. So after that, we decided we had to have a quiz for every single lesson because it was wonderful. So, and again, just to follow on, people like in our lesson, they like the quizzes as much as the food. So it can be done. So the next thing, and this is the newer part of our courseware, is we're professional programmers and we're always experimenting with new languages. So we were at an Agile conference in the Pacific Northwest and we saw a group of people pairing learning Ruby and there was no teacher. We're like, how's that happening? And they were doing Ruby koans. So the idea of a koan is a class that has a bunch of unit tests in it that fail. And you work as a group, a mob, or a pair, and you figure out how to make the test pass. And then the koan aspect comes from the martial arts, where you're practicing karate or whatever. The idea is you do the thing, and then you reflect on what you learned. So the important part of the deep dive is not necessarily to get the test to pass, it's to then look to your partner and say, what did we learn? What did we learn? So what does this look like? And again, what we do with this is we do go a lot deeper. So let me go, this is the one for the first one. So let me go up to the top here. And we have the instructions here. So let me get one that's failing. Okay, strings do not need quotes. And then we go ahead and we run a test. And we can see that fails. And then, again, these are 11-year-old kids doing unit testing, or looking at unit tests. And then we get them to read the error message. So sometimes the thing they learn is there's a thing called a test, right? I mean, it might not be like about this particular thing. Again, we're trying to get good habits. You notice here we've got expressive method names. So sometimes they take a little while to figure out to read the method name, right? For a hint if they're stuck. So then they get it to pass. And then once they get it to pass, then we say, what did you learn? And they'll make some observation, and sometimes we record them, sometimes we just listen. And then sometimes they'll say, well, what if what if it was like this? We love that, right? What if it? So what do? Well, try the test, right? You say, oh yeah, it's case sensitive on a string. I got it. What a great way to teach that, right? Rather than the boring PowerPoint, strings are case sensitive in Java, right? Like it's super fun. Like what if, what if? So, we get into, and this is the first lesson, we get into, some pretty kind of, hairy stuff for 10-year-olds. Let's see, we have stuff like this. Okay, this is a pretty good one. For loops can start anywhere. Okay, so you only fill in the underscore. Okay, so let's see if you guys can get this in the room. We should have somebody who can figure this out. Okay, so we look here, and what should we put in here? Who knows? Who can yell this out? What should we put in here? Jessica cannot answer. You cannot answer, people that know the courseware. 7? Okay, let's try 7 and see if it works. Oh, look at that. And why is 7 the most feared number? Because 7, 8, 9. Oh, 11-year-olds love it. Okay. Think like an 11-year-old, okay? They love it. So a teaching technique that we've started incorporating, it's kind of interesting that Woody Zuhl is actually here. I don't know if he's in the audience, but you know, Woody has gotten quite justifiably famous for the introduction of a new technique called mob programming or group programming. He's done some workshops and presentations here. And I know Woody, he lives nearby, and I've actually worked with a mob, as an aside. So we started doing mobbing with the deep dives. And this is actually my daughter, and this is her former middle school. By the way, that's her former history teacher who took her class when she was 13. And she taught him to program, and now he's teaching. It's kind of cool. And this was actually last week, and they're learning what we just showed. They're starting the year, they're learning for loops. And they're mobbing. So it's kind of a fun thing. And again, this just shows the rich feedback there you can try and run. We recently added written workshops as a compromise with the school teachers. They love the written printed workshops, worksheets and lessons. And not to be facetious, it's to reinforce programming concepts. But notice where we put that, at the end. That's at the end, not at the beginning, okay? So our repositories are in GitHub, and you can see there we have the downloadable jar file, which is under teachingkidsprogramming.java. We have the source for all the wrappers and things that we've written on teachingkidsprogramming.source.java. And then we have the virtual proctor there as well. The pen flip, which is the book, is over here. And it is, like I said, about 150 pages. You, as programmers, it's a GitHub for writers, so you could fork it. Like if some of you here got ambitious and you wanted to do a Swedish translation for use here, be fantastic. And then the school teachers can print it. Or they can use it online too, but I find they like to print it. All right. So future, looking forward. Let me go up one there. I skipped something. No, I guess I didn't. Okay. So looking forward, one of the big blockers to this has been schools are a really hard time installing anything. And installing an editor and a customized environment, as much as we try to make it one click and all that, it's just really, really difficult. So I've done some professional work with this company called CodeEnvy. And they offer customizable developer environments as a service. And they've actually just recently launched a substantially enhanced new version. They're, some of you might know of them. They're originally Exosoft out of France. And they have generously committed to give us premium access forever. And I'm saying this on the video, so CodeEnvy, you're on the hook now. So I am working with their engineers to create a series of, these are called factories. So I'm going to show you a bit about this, but be patient with me because my servers are in the US, and they actually pushed a new build inconveniently an hour before this. So, okay? I'm going to try, okay? So it is very early. We don't have a full implementation yet. So the first thing is I'm just going to show you this example. Let me see how I'm doing. Pretty good. So this is their work environment. Now this would be for us as developers. We would create these customized environments. Oh, I launched it a couple times. And then we would save them as factories and permission them. So it would basically be like web endpoints that we would give to our teachers and students. Everything is customizable. They have an API. So in the immediate term, I just want to translate what we've done in Eclipse into CodeEnvy. In the longer term, I want to include event handlers so we can hook into behavioral capture, kind of like the Khan Academy does. So we can use it first in aggregate to improve our courseware. And ultimately, my vision is to create personalized courseware. So anyway, if you've never seen this before, this has got 3 environments. It has an editor, and it has a builder and a runner. And again, from a technical point, these are clusters of servers on the cloud. Happens to be, I think, the Amazon cloud, but I'm not sure. So this is just a typical Java project here. And let me show you what it looks like. This doesn't have our library in it. It just has kind of a fakey hello world thing because it requires Maven, and our library was built originally with Ant. So I'm still doing the translation. So you can see it has code completion, hopefully. Very brave of me, isn't it? Hopefully, hopefully, hopefully. Maybe not. Try it again if it doesn't go. And normally, when I have good Wi-Fi, so all of you on your phone, get off your phone. Anyway, and then it has the ability to build and run and then view. So it's a full-on environment. While this is spinning up, it's also collaborative. So it's got a Google Docs style collaboration. So one of the other things we envision is kids being able to work with other kids, pair with anyone around the world. And it uses really modern technologies like Docker to spin up the runners super, super fast. So normally super fast. So another reason that I'm interested in working with them is, like I was saying in the beginning, we're looking at other languages, and they have support for C++. Not that I would be a horrible person and teach kids that, but Python and Ruby as well. And now the runner is up, and for this particular implementation, you know, I did the little hello world thing here, and it's going to have latency because it's, again, you guys are geeks, so it's capturing browser events and sending them back to a server. Okay, so it's going to take a minute. But can you see where the vision is going with this? Yeah, it's like super exciting, I think. Super, super exciting. Personalized programming environments for our kids, right? Why not? Why not? It's going to take some work. So again, if you're interested in working with me on this, I love to remote pair. And I'll work on your time schedule. Yeah, this is going to just sit there a bit. So I'm just going to try one more time. Well, while this is going, let me just, there's my repository. So welcome to join in the repository. The other thing is we forked the repository. So I forked it with the CodeEnvy people. So the main branch compiles with Ant. And this is the download right here. Here's the instructions for installing. So you literally just download. It's a jar file. And if you want to work in the CodeEnvy environment, that's a new fork. So let me see if that is good. Over here. And oops, that's the Python. And there it is. Sorry. There. It's going to be slow. So you guys see how it goes. Again, seriously, it's a US server. I was like, duh, I should have put it in a European server, but didn't do it. So, and you can see there is a screenshot of what it looks like. We also have full customization over here as well, so we can put all kinds of fun messages and neat stuff. So again, if you have interest in working with teaching kids programming on this, we are really actively looking for people to work with us. So, all right. So the courseware, I focused on the Java courseware. There is an existing set of courseware in Microsoft Small Basic that we're no longer maintaining, but because I know there's a lot of Microsoft people here, it's a perfectly fine language. It's a similar set of implementation, not as extensive, but it's out there and it's on Codeplex. So it's a set of C# extensions, and if that's more conducive to your environment, go for it. I've also done extensive work with another visual environment called Microsoft Kodu, which is, again, kind of peripheral to this talk, but just so you can understand kind of the scope of what we're trying to do. Kodu is a storytelling environment. I was involved in the beta for that, as was my daughter. And I actually just released a course on, it's lynda.com, on Kodu. Also looking at Project Spark. As I listed here. We do have a course in relational databases. This is when I was working with the high school girls. Don't laugh, okay? Our course is the boyfriend database. Okay, that's how we teach queries, right? Hey, they're into it, man. And then we had one for boys. It was the insult database. Okay. You got to get stuff that kids are interested in. I professionally, like I said, work in cloud and big data. So we're also starting this project. Actually, I'm going to just mention what Jessica's doing with the Boys and Girls Club of San Diego, where she has this beautiful property. It's a farm, basically an industrial kitchen. And she's taking lead on this property that we're calling the Internet of Things Farm. So again, while we're hanging out, because we'll be at the conference, we're starting to explore, censoring the ground and then using that data as data for kids to work with from a sort of a data science standpoint. That's a new project that we're just starting on, which we're really excited about. And we're talking to the Wolfram language people, and then I'm data science geek, so we should use OR, So those are kind of the areas that we're focusing on right now. So there's the class from, let's see if I can say Landskrona. Is that close? Okay. There's the class. That's how they looked after spending 2.5 hours with me and their dad and their mom with Java. And they did a great job. And I guess, from what you said, you're going to continue on in your school. And so at the end, again, if you want to talk to Mateus about what the experience was like teaching, co-teaching, and as he continues on, if you're interested in talking with him, he'll be a great local resource. So to that end, I listed his name and his email, as well as mine. And I hope that I've inspired some of you to start teaching. Thank you very much.